Hello, kaya muli bwanji nonse. Tafuna ndikulandireniso kutsiku la lero pamene tikufuna kupitiriza phunziro lathu la trigonometry. Today we are in lesson 4. Ndipo mu lesson 4 imene tikhala tikuona bearing. Ndipo muli ndine Sisero Juma nthawi zonse. Tikakamba za bearing, tukamba za that is in mathematics. This one is the angle which is in degrees, mostly measured in clockwise. Not measured in clockwise, it means we have a reference point. Okay, we have that reference point. Mostly makala north and there. That reference point makala north. Okay, so we measure our angle in a clockwise manner. Clockwise like that. Okay, so a bearing angle, the bearing is the angle which is in degrees but has to be measured clockwise. Which means if you measure it anti-clockwise, according to this definition, that one is not a bearing. But if you measure it from that reference point of the north, going clockwise, many pang ear and la watch, that is bearing. And the bearings are usually given as three figure, as three figure. For example, you can have an angle of 30 degrees. Let's say that's your north, and you have an angle. Let's say that one is 30 degrees. And for you to name that one into a bearing, you will say it's 0, 3, 0 degrees. Okay, because it's going clockwise from there to this side. So this is what we call a bearing. That's bearing. An angle measured in a clockwise from the north. Okay, from the north, that's your reference. North is our reference. From there, if you measure it clockwise, you get a bearing. But make sure it should be a three figure. Okay, remember that one can complete a cycle, and in a cycle you have 360 degrees. So bearing is a three figure thing. The number of makana figure atatu nditu. Many one many. This is a bearing. That's the angle 30 degrees, but that's 0, 30 degrees, 0, 3, 0 degrees. That's a bearing. Now, problems involving bearings can be worked out as you would work out problems with triangles using trigonometry. At this level, that is. At this level, we cover the SOHCAHTOA, that is those trigonometric ratios is made na takatu kupanga ma lessons atatu apita. So all those trigonometric ratios can be used to determine my problems ametinga kumane now kupanga solve bearings. Let's have an example. Let's look at an example. In this example, a boat starts from point A and sails to point B on a bearing of 30 degrees. Given that the distance of A to B is 80 meters, how far B is to the east of A? First of all, you need to imagine this scenario, and you need to put it into a figure. Make sure that in this scenario we are using trigonometric ratios. So whatever figure we are going to make it a right angled triangle. Make sure it's a right angled triangle. For example, they're saying a boat starts from point A. Let's say that's point A. That's point A. and zeros to point B on a bearing of 30 degrees. Okay, that's point A. So you need to have a reference. The reference is the north. Town as many as reference in north. So that's N, north. So a bearing of 30 degrees, which means from north you have to go clockwise. And then abaja, you move in a clockwise manner for you to have a bearing. So we measure 30 degrees. Okay, so this is 30 degrees. Okay, 30 degrees is this angle. Okay, and that's point. It's moving from point B, A to B. Okay, and the distance of A to B, distance of A to B is 80, which means from there to that point is 80 meters. Okay, which means that distance, which means AB, let's just put it here, AB about Bambari is equal to 80 meters for us to keep in, to remember it. Now the question is, find how far B is to the east. How far B is to the east of A. How far B is to the east of A. Yeah, so the question is, find how far B is to the east of A. Okay, so I hope in geography munapanga cover naming of directions. You have north, you have south, you have east, and you have west. Okay, so in this case they are saying how far is B. Okay, we have like that one is B. Remember that one is theta. Okay, how far is B from point A? That's our point A to the east. To the east, which means it's from A. The east of A is to going towards B. So B is located at the east side of A. So how far? So you drop a line from there, which is perpendicular. Okay, now for you to find that distance, okay, we can label this one as C, that point. It's from A to C. Hope that is making sense. So basically, if we are to go back to this one, you will find out that they want us to find that distance. You drop that perpendicular line there. Okay, we can label that one as a C. Yeah, so that is a 30. And this one, remember, Ababa 90, Abba 90, Abba 90, Abba 90. So, kumamba kuli 30, and then Abba pali 60. By now, you have to understand what I'm saying here. Okay, so we have a triangle ABC, which you are given AB as 80 meters, which means you have a right-angled triangle which has an angle of 60 degrees and hypotenuse is given as 80 meters. So if you are to use SOHCAHTOA, let's put up SOHCAHTOA here, because we are going to use trigonometry. This is a right-angled triangle. You have hypotenuse and you want to find this one. Now it's adjacent. You have hypotenuse, you want to find adjacent. So we are going to use CA, adjacent and hypotenuse. Okay, so I'm going to use that. So the CA is on CA is cosine, cos in this case 60 degrees, should be equal to adjacent, which is AC, over hypotenuse, which is AB. And that one will be equal to AC, we don't know, it's the one that we want to find, and AB is equal to 80 meters. Now we make subject of the formula AC. It will be AC will be equal to, okay, it will be 80 times cos 60 degrees. Okay, so let's use our calculator. Okay, here's the cos. Yeah, you take your calculator, you go where there is cos. That's cos 60 degrees. Cos 60 degrees is half. If you multiply by 8, to give you 40, which means AC will be equal to 40 meters. In other words, this is a 40, B is 40 meters away from A as you go towards east. Let's have a look at another example. In this one, they're saying a ship sets out from a point A. The same thing, you have to imagine. Let's say that's point A. That's point A. And sails due north. So that they are in there, going towards north. That's your north. To point B. Okay, maybe yes, that's point B. And a distance of 120 kilometers, which means that's 120 kilometers. Okay, 120 kilometers. And it then sails due east. Where is your east? Let's just put that compass there. That's north, east, west, and that's south. Okay, and we can as well put this Sokato aside. Okay, and it moves towards east now. It's going there. It then sails due east to point C. It reached the point called C. If the bearing of C is 0.37, okay, remember it moved from north to east, it moved 90 degrees, which means that angle is 90 degrees. Now the bearing of that line is 0.37 degrees from A, from here. So you connect them. Sorry. Connect them. This bearing is 37 degrees. Okay, 0.37 degrees. Yeah, so if you look at that, you also have a right angled triangle, that's 90. This angle is 37 degrees. A ship so the first question should be find BC. Find BC. BC. Okay, so you have right angled triangle. This is the angle 37 degrees. That's 90 degrees, which means your hypotenuse is AC, your adjacent is AB. In this case, you have hypotenuse and you have adjacent. Now you have been asked to find BC. Okay, so but that one is opposite. It's obvious there because you have adjacent, opposite, and that angle. You have adjacent and opposite. You can use TOA, opposite and adjacent, so you can use tan. Tan 37 degrees should be equal to opposite, which is BC, over adjacent, which is AB. And BC in this case is not known. This is not known, but AB, we have noted that it's 120 degrees. 120 kilometers. We do the same. BC will be equal to making BC subject of the formula, so you will have 120 multiplied by tan 37. Okay, so you do that on a calculator. You punch tan 37 angle, then you multiply that by 120. It gives a distance of 90.4 kilometers, which means BC will be 90.4 kilometers. In other words, C is at 90.4 kilometers to the east of A. Yeah, so reaching that far, I think for today that's enough. That's what I had for you. Let's meet again next week. Thank you.